the explosion case. Two stationary objects of mass 1 kilo and 2 kilo. No velocity, so I'm not writing anything above those boxes at the moment because there's no movement. When they're released, the 2 kilo mass moves off. At 4 meters a second east. And what we want to know is, what's the velocity of mass 1? Well, if we add up our momentum of the system over here, remember our total momentum is equal to the mass times velocity, there's no velocity, so there's no momentum. And that means that we have to end up with no momentum after the explosion. Now we do know, we can work out the momentum in this direction. So we have m1 v1 plus m2 v2 is going to equal 0. We know everything that we need to know about this one. It's 2 times 4, and that's a positive 4 because it's travelling in the easterly direction. We also know the mass of this one, v1. So we'll have 0 is equal to 1 v1 plus 8. Yeah? Now I'm going to subtract 8 from both sides. So I end up with negative 8 is equal to 1 v1. And if I divide both sides then by 1, I get v is equal to negative 8 meters per second. So what does that tell me? It tells me that it's going at 8 meters a second in the other direction. And that makes sense. If I look at this, this one has half the mass. So if it's got half the mass, it should have twice the velocity. So we need it to add up to 0. Okay, so one more worked example, I think. And then we're on to questions. What do I want you to be paying attention to? Drawing out what's happening, the way I draw it just with boxes is the easiest way to do it. If it could be ice skaters, because anything that's in a low friction environment, etc. Don't bother trying to draw human shapes because it's a waste of effort. Just boxes is enough to represent what things are. Okay, so Ted is running to the right. This is Ted, and with 45 kilograms. It's running to the right, 8 meters a second, and in a game of touch football collides front on with Alice. This doesn't sound like touch football, 65 kilos. Sounds more aggressive than touch football, and she's running to the left at 9 meters a second. During the collision, Alice gives Ted a little shove, so Ted finds himself moving to the left.
Little shove.
At 4 meters a second. he's still 45 kilograms. Immediately after, at what velocity does Alice find herself moving? So we want to know the velocity of Alice. So remember, the total momentum of the system, m1 u1 plus m2 u2. Ted is 45 times 8. Alice, we're going to add that on. Hers is 65, but this time it's multiplied by -9 because her velocity is in the negative direction. And apparently this adds up to -225. So that's our before. After, we know then for m1 v1 plus m1 v2 m2 v2, you've got 45 then multiplied by -4 plus 65 v2. And we've got, this is then minus 180 plus 65 v2. So these are equal to each other. We're going to add 180 to both sides. And what do we get? 45, is it? Yeah. So we have -45 is equal to 65 v2. We're going to divide both sides by 65. V2 is equal to -0.69 meters per second. Okay, so that means that, what's her name? Alice's velocity, she's also moving to the left. But we don't need the negative sign and left. If you say them both, then it's a double negative. And we don't know that if we have the double negative, then that would mean a positive. So we we leave off the negative sign when we're writing the direction. All right, so two pages of examples to work through.